We are now going to discuss the total gunning system, which consists of gun, water supply, air supply, and material supply. The first on the list is the gun. This is the REED LOVA machine for dry mix spraying. Dry mix material is entered into the top of the machine and comes out of the gooseneck through the material hose to the nozzle for spraying. Next on the list is water supply. George?
Why is water important? Most materials that you will apply with this gunning unit, the moisture addition and the strength properties are two parallel lines to the slump point. It's very important that you get that water mixed thoroughly with the material. The water is mixed at this point through a water ring that is controlled by the nozzle man. This particular water ring has 12 1/16 holes. It forms a wagon wheel type pattern, and it must have enough pressure to penetrate that mix. This air material velocity coming through this point is measured by a gauge on the gun, which can be called nozzle pressure, but technically it is a measurement of velocity of back up from the wetting point. At this point, it must have at least twice the water pressure as that registered on the gun at the gauge on the gun. A good safe practice is to always use a water booster pump. You can have them air operated or electric operated. The main thing is to get the pressure at least twice, and a good safe practice is to always go to about 120 psi on this gauge at the pump, and always have a 3/4 supply line and a 1/2-inch line going to the nozzle. And this should be operated so that you can provide the proper pressure to give the proper wetting or the proper hydration of any material exiting from that nozzle. Okay, Rich, back to you.
Okay, next thing on the list is air supply. The air comes into the machine from the back end, and it's very important to use the same size air line as you're using material line. For example, today we're using an 1¼ air line and an 1¼ material line. It's very important to keep that the same. Air pressure is very important. Air PSI should be between 80 to 100 PSI, and CFM can range from 250 up in excess of 1200 CFM. Today we're using 365 CFM with this application we'll be spraying today. Next is material supply. It's a very wide range of materials that can be used with the REED gun, from refractory materials to sand and cement, to sand, cement, and rock, to backfill materials with rocks exceeding from 1/8 inch up to 3/4 inch, including 100% backfill of 3/4 inch rock and 3/8 inch in sand materials. Next, George is going to discuss loading the machine.
There are many methods to get the material into this gun. You can go from the plain old shovel onto conveyors, onto screw-type conveyors, belt conveyors, any method, or sometimes the material does not require anything but taking the bag and placing it over the bag breaker. The idea is to keep the gun at least 2/3 full of material. This is very important for the blowback on the unit as it rotates. Going into pre-mixing, many materials, especially refractories, anti-acid materials, many of the materials that must be pre-mixed with water. This can also be done by just a plain old paddle mixer. It can be done with a screw conveyor, which is very nicely gradually feeding the REED gun. There are many methods. The important thing again is to keep that hopper 3/4 full. Now, pre-mixing has many advantages, and it's very simple. It does require the extra equipment, but it's very simple. But for one thing, you must realize that the refractory or the bag material segregates very badly as it's being shipped to the place of installation. Therefore, it's very important that the mix be placed back into its proper mix as it was manufactured. And also, it contains some 200 and 300 mesh materials which have a tendency to block air. And this is where the premixing definitely helps on flowability through the hose and all the equipment. It's very important. And you actually coat the larger pebbles with some of this 200 and 300 mesh material. A good check, and normally the range that you will find most suitable for the dry type gunning machines would be in that 3 to 5% range. A good field check is to always go up, and after you've placed the proper amount, which a pound per pint is sufficient, or in other words, if you're going to place 200 pounds in, you would have approximately 6 pints of water. And usually you get a can that holds approximately, or mark it so that you place the same amount of water in at all times. This is very important because you are adding probably at a total of maybe 7 to 8% water at the nozzle. So if you vary this a percent, you're going to throw the nozzle man off immediately. So it's important that you keep the premix at a definite 3% or 3.5%, whatever you set on. The premix, the field test that can be used is nothing more than after it's been premixed to probably a minute, minute and a half, is to pick up a handful and see if you can form a ball. And if it falls apart in large pieces, you're normally right in the 3% range, just where you should be. If it stays in one ball, you naturally have too much water. If it falls apart in fines, you are too low in water. This is a very simple check, but surprisingly very close to what you really need to get good flowability through the gun and the machine. The gun and machine and hoses. Definitely there are many reasons. We mentioned flowability already. It's a definite help on flowability. Also, something that is pre-mixed with water is going to accept water at the nozzle much quicker, more readily. This is very important. And also, pre-mixed material will eliminate any static electricity that you might have created by the coarse particles of a mix, which can be quite shocking to the nozzle man at times. And this will eliminate this static electricity. In all, pre-mix can definitely reduce rebound, and this could be as much as 50%.
Next, we're going to discuss the operation of the gun and nozzle. George?
We will actually start up and shut down just as if you were on the job site. And this is a first time for gunning on this installation, so naturally you have not established an air requirement or a material feed requirement. But we will show you how to adjust to get this and then remain at that constant nozzle velocity and material feed control. First, you would start your get your water pressure to the nozzle man. The pump is going, and he has his proper water pressure. Then you would turn your main air on with this valve off. This valve is off now. The main air valve is opened up. Then you gradually introduce your air into the system and watch your gauge. And you would normally go up to approximately 20, 25 pounds on straight air. That's straight air now. And then you would open your main valve on the material control or feeding system. Open that wide open, and then you gradually introduce material very slowly. And if it's possible, try to get your hand on the hose and feel how smooth it's starting to become, and rather not surging. You want it to start flow through just like as if it were water. Gradually introduce material in, and your pressure now will go up to probably from 25 to approximately 35, 40 pounds. And then from this point on, it's what the nozzle man wants and can handle, and can the area he must work in, what thickness of lining he's applying. The production rate will depend strictly on that, how much he can handle. All right, you're satisfied. Everybody's happy, and you want to shut down for a coffee break or whatever. Now, all you must do is just, first of all, you will turn your material feed off. Always turn the material feed off first. And all you have to do, you do not do any adjusting. just shut it off. You've already established the material feed control. This is just shutting all material off now. Wait about a minute so that hopefully there's no material in the line, especially if you have high elevations. And then cut your air off, but before you cut this off, the nozzle man will actually flush out his nozzle and clean it out good with the high pressure water and straight air. And then you cut the air off very slowly. Don't shut it off fast, cut it off slowly, because sometimes at high elevations, some of the heavier weight materials, it can fall down the 100 feet elevation or whatever it may be inside the hose and accumulate at the bottom, creating a plug. And the final thing you would do is shut your water off to the nozzle. Shut your water pressure off to the nozzle. You do not want to leave that water pressure on at all times when it's not in use. Now we'll go to the nozzle setup. This is where you control the water amount to get the proper mix. And normally you would open your water before he starts the material to check, see if you have your water adjusted properly, and gradually open the water as he introduces material into the stream and get your mix. And on any mix, you should always take it up to approximately the slump point and then back down to get the proper placement. This is where you're getting the proper water in, remembering the water and strength properties of any mix are two parallel lines. So it's important to get this water up to almost the slump point and then back off just a hair. And to help on that, we have a 3/1000th WOG needle valve here to give fine control. Because keep in mind, you're adding sometimes only 3, 4, 5% more water at this point, and you cannot control with a globe or gate type valve. You just can't control it. And you're mud dust all the time. There's no way you can eliminate it. So this gives you, with the high pressure water and the needle valve, gives you very close control of that water and instant change. And this keeps from getting into mud, wet, dry patches on the wall or whatever you're gunning. And always try to keep the nozzle at a point approximately 45 degrees from the waist down, as if you're building a shelf all the way up, and try to gun the full thickness if at all possible. Try to gun the full thickness and take an area of, say, 2 to 3, 4 feet and bring it up as high as you can and still maintain that somewhat 45. Anytime you get past the perpendicular angle, you will start getting more rebound all the time. From here on up, you'll get more rebound. Stay down in this angle, shoot in the shelf-like pattern at all times. Try to bring it to the full thickness. And you will see when we're starting to gun later that we are placing approximately 1.5 inches over the tips of these anchors. The anchors are 2.5 inches from the wall.
Prior to gunning, I'd like to go through all the inner parts of the machine, give you a good idea of the maintenance. First, I'd like to, before we start, is make sure the spindle area is very clean. Take a light-duty emery cloth, clean all this, make sure there's no debris whatsoever. This must be extremely clean, the spindles and the shaft. The complete area.
That's a very good idea to put a light coating of grease on the steel studs and the spindle.
Okay, next is the riser plate. It's very good to hit this again with the emery cloth. Make sure it's very clean. Next is the feed bowl. This is a 21 pocket feed bowl that we're using. Like to hit the bottom of this surface, make sure it's very clean. Make sure there's no nicks or debris on the bottom of this. Like to make sure the top surface of this is very clean. And again, hit it with emery cloth. It's good to hit every web. Make sure there's no debris whatsoever. In between as well. If you were to find a nick, it's good to file that down until it's completely smooth.
Then again, applying a thin coat of grease on the surface of the bowl, just a thin coat of grease applied on all the entire surface of the bowl.
Okay, now the wear plate. The bottom section of the wear plate must be very clean. Again, same thing as the bowl. Make sure you hit it with emery cloth so there's no nicks or debris on all the webs. Very clean.
It's very important that these pockets are in direct alignment.
Good to clean this. And again, doesn't hurt to hit this with emery cloth as well. And it's good to swing this very hard. Lock that in place. Drop the pin on the side. Next is the agitator. Next is the rock shear. The rock shear goes down in this housing here.
The placement and the adjusting of this rock shear is extremely important to determine the total life wear of your wear plate, rubber pad, and normally it is placed so that a business card, a normal business card, acts as a shim underneath and must have a uniform pull and the full width of the rock shear. Then after you feel that it is adjusted properly, you tighten the 2 bottom bolts first. Check your shim, and as long as it is adjusted properly, then get your 2 top bolts tight. And this rock shear determines how long your rubber pads are going to last, and in turn the wear pad also, the wear plate.
Okay. The next thing is the gooseneck wear pad installation. It's very important to make sure the bottom of the pad backup assembly is completely clean, and also the wear pad. And this complete housing is very clean. Yeah, the oil, George. I like to take a very light film of oil and just put it on the very top surface of the wear plate. Also, on the bottom of the wear pad, just a very small, light amount on the wear pad. Then insert it and it's very important that this lip goes all the way in and has a very tight fit. Then bring up all your studs.
It's very important that this base to the cone outlet, this rubber pad, and the pockets all are in one alignment. This is, if you ever change any one, then the entire assembly must be changed. This base of the cone, rubber pad, and the wear plate and bowl all must be in alignment, both holes. And this unit is placed in as far as it'll totally go. Okay, then you start adjusting very uniformly the pressure on top of the plate. And this plate must be on the wear plate. This rubber pad must be on the wear plate very uniformly.
He's bringing them down so they all 3 touch evenly. Now they're all evenly tensioned, very lightly.
Okay. When you feel that you have the proper adjustment on these 3, then you place the
swing away pad clamp and the C clamps in place. Okay, now you put on your hose. It's very important to put this last. If you don't, this very stiff hose will bind and pull this housing away as you're trying to adjust the wear pad. There you go. Next is the adjustment of the felt seal. It's good to take a little bit of oil and pour a light stream over the top of that felt seal. Any oil that goes on the wear plate is okay.
It's best to check to make sure that the bottom of this felt seal is bearing strongly on the surface of the wear plate. This is very important in that this can cause material blowback very quickly if it is not bearing right on the wear plate itself. If it is not bearing down on the wear plate in a section, you would just take a screwdriver and push it down so that it is bearing on that wear plate.
Yeah. Let's go ahead and show them that, George.
All right.
It's a good idea just to show them how that works. You can't put too much tension. If you really push it down real hard, that's okay, to make sure it's sealed really good. If it wasn't making a good seal, you'd get a lot of material leaking through the bottom of the housing, right through here.
Feel at the bottom of this steel band here, if it has a good bearing right on the plate. It can't be too much. Quite often this is where the blowback problem appears.
Okay, next is the hopper.
Oops, that moved.
The screen. The bag breaker.
When this, to assure your rubber pad has been sealed properly on top of that wear plate uniformly, when you start to rotate the motor just very slowly, it'll actually have a little pull on it. And it must be rather, you'll almost hear it squeak a little. It must pull just a little bit. And that means you have a good, not too much, but you have a good bearing on top of that. And this can, if it's not sealed properly, this can cause early failure of the rubber pad and wear plate both by allowing large particles to get in that space. Next step is to install the main air supply hose to the gun.
Okay.
From that point on, the material hose is attached.
Now we're ready to gun.